So geology is an area of earth science which looks at the earth's physical structure, the rocks it's composed of, its history shown in the rock layers, and the processes that change it over time. And even in elementary school in science, they're looking at all different, the different aspects of this. I also, I do city classes through the Seasons catalog for elementary school kids. And on one of the weeks, I do have them look, and I kind of give a little description of all these different occupations, and I ask them which one touches them, which one are they most interested? Because when they come, some kids like fossils, some kids like gemstones, some kids like outer space, some kids, it really runs the gamut. So it gets them to think a little bit, and then sometimes the kids are even like, well, we both like gems, maybe we should own our own store together. They get all these cute little schemes in their minds of fun things that they can do when they grow up. And it really covers so many different aspects of our earth. One of the things that we cover in 5th grade are Earth's 4 spheres. So the atmosphere, the biosphere, the lithosphere, which is often called the geosphere, that's the way I refer to it, and the hydrosphere. So anything that has to do with the air is the atmosphere. Biosphere is any living things, plants, animals, human beings. The geosphere, anything that has to do with land. And hydrosphere, anything that has to do with water. So then once we kind of brainstorm, what things in nature, what of those 4 categories do they belong in, then we talk about, well, how are they connected? Because every single one can somehow be in relation with the other. So like the easiest one, that I start off with to get them thinking is we are part of the biosphere, but we need air to breathe, so that's the atmosphere. We need water to survive, so that's the hydrosphere. And we live on land or on Earth, so that would be like the geosphere or the lithosphere. So we look at the connections between each one of those. And so that's like 5th grade that they look at that. Oops. There we go. Okay, so the building blocks, if you put a bunch of atoms together, you get an element. You put a bunch of elements together, you get a mineral. You put a bunch of minerals together, you get a rock. And so people are often, and it's not a big deal, but they'll say, well, what rock is this? But it might technically, be an element or a mineral. And you could go back the other way. Rocks are made up of minerals. Minerals are made up of elements. And elements are made up of atoms. So atoms, some, the older kids have heard of them. The little kids really haven't. But they've seen maybe the symbol from like Jimmy Neutron or Big Bang Theory. Like many of them have seen this symbol before. So I might, if it's an older class, I might just say, well, we've got protons, neutrons, and electrons. You can't see them, with the naked eye, but they are the building blocks of elements. And then an element, and then we talk about the periodic table, which I'll show you in a second. A chemical substance that cannot be broken down has only one type of atom and the same number of protons. And there are many things that we don't even realize that they're elements. So here are the periodic table of elements. So back, we used to have this in high school chemistry, but they're now introducing this in elementary school, which is, personally, I think is a little scary, but I think a little introduction is fine. I think I do bring it into my classes so then that when they see that, maybe they're not quite as scared about it.
You say elementary, do you mean 5th grade?
Someone told me 3rd grade, wow. But I think, I don't know, but then I've asked some 3rd graders and they say they haven't had it yet, so I don't know if that person misspoke.
What level do you teach?
I used to teach kindergarten and now I sub for all the lower grades. And so for the city, my seasons catalog class, it's called Earth Explorers, so I do a little bit of everything, so, a lot of what you're seeing today. And then I also have a dinosaur class, which is just kind of cute and fun, and, and it's mostly made up of 7-year-old boys. So anyways, the basics that I just cover with the periodic table is that an element can be a gas, a liquid, or solid. And there's many different versions of the periodic table. I do like the ones that are bright. My poster, it has the colors of just which ones are gases, which ones are liquids, and I think there's only like maybe 2 liquids, and then mostly solids. And so we talk about how every element has like a chemical name. It's like its nickname, you know, so like aluminum is Al, oxygen is O. And I also talk about how when we get into this, have you heard of H2O, what H2O is? So most of the kids have heard of that, so then it kind of makes them a little less scared of this. And just saying that that just means that water is made of H, hydrogen, and O, oxygen. So then it kind of makes sense for them. Because when we get, and I'll show you when we go on to minerals, every mineral has a chemical name where it's all of these elements put together, and so it kind of carries on to the next level. And then what I do is we have a little game where I have about 12 elements. And I said, now remember, they're all solids because I don't have any gases because that would be cruel. But and then they have little cards with like the, you know, P or S or CU, and they have to kind of find it, and then we kind of go down till all 12 are done. And that's about all that I do with it. Yeah.
We were remembering the periodic table as the hydrogen being on the left. So are there different?
Mine I believe is on the left as well. So there are different. Just the way that it's. I mean, there's certain categories. You know, there's certain rows that they have to be in. Oh, and the other thing is the number in the corner is like the number of protons. So, but yeah, that's why I never took chemistry. Okay, so, this keeps going fast. Okay, so minerals. So in the back, when we have our exploration time, in the back, those are all minerals. None of those are rocks. So, and that is really what kind of got me hooked into geology because they're so colorful, you know. There are over 4,000 different types of minerals, but only a small fraction make up the Earth's crust. So a mineral has to be solid form, so it can't be a liquid or a gas. It has to be made by nature. It has to be inorganic, so it can't be alive. There has to be a crystal form or structure. We don't always see that in the minerals. Sometimes you do, sometimes you don't. And then the chemical formula is what we just talked about. So these are some of the mineral groups. I really don't go into this with them because then we just kind of get too deep in the woods with the chemistry aspect of it. These, just if you're wondering a couple examples, these are all minerals, and you'll see a lot of the minerals end in "ite." And so these are just some of the examples, you know, for those different categories.
You tell the kids?
Oh, sorry. No, I don't really I don't really do this with the kids.
No, but I was wondering,
Oh.
a bunch of names. You tell them something like, well, people have given these names to the minerals over time. You know, is there some naming?
You know
story?
what? I do that with the periodic table because then I say, oh, well, have you heard of copper? Oh, yeah, I've heard of copper. Have you heard of gold? Yeah, of course, you know. So I go through all the ones, you know, that are really common. And then I might say, well, have you heard of, and I'll go through like some of the really, really funny names, you know. And then I'll say, well, a lot of these were named after like the scientists that discovered them.
Do you find that that you can relate a little bit to Minecraft?
Yes, I will get to that in a second. Absolutely.
Spent about half an hour at the Museum of Natural History in their gem area trying to find the lapis.
And lapis is a metamorphic rock,
Right.
which I always thought was a mineral, but it's a metamorphic rock. But the other thing that I do that we go through with the minerals is the properties or the characteristics. And so these are like little tests. So I tell them, pretend like you're going on a scavenger hunt and you find a mineral and you don't know what it is. You can get all these clues and put them together and find out what the mineral is. And this is, and I brought these so if you wanted to look at them later, this is a mineral identification book, and so it has, like you start, with streak or hardness or luster or any of those, and then you kind of, you get down to like where you've got more and more clues, and to try to find out what the mineral actually is. So color is, yeah.
Do kids get what the word property means in this regard?
I like I said, I just kind of like when I explain like these are characteristics, or these are like little clues, that, so for instance, I say, so let's just say you find something that's yellow and, which isn't a very common, not quite as common, and it smells like rotten eggs and you're near a volcano, it's going to be sulfur, even though sulfur is an element, but because odor is a very, very rare property or characteristic or clue. So color is what you see with your eyes, which is different from streak, which is the other kind of color, because some minerals can come in different colors. Fluorite, which is one of my favorite minerals, can come in green, blue, purple, white, and yellow. So you can't really use that as a definitive clue, but just one of the many clues. I'm going to jump down to hardness. This is a hardness kit. And if you ever find one of these, I will pay you for it, because I think the man that made these passed away, and so you can't find these anymore. And these are just the best. It's a hardness kit, and in it, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. So the hardness, there we go, and I will leave this out for you to look at as well. So the Mohs scale of hardness goes from 1 to 10. 1 is the softest, which is talc, so 1 and 2 you can scratch with your fingernail. 10 is a diamond, so then we talk about, well, why is there not a diamond in here, right? Which, and they get it. So for instance, let's say you have an unknown mineral and you want to find the hardness. So let's just say I'm going to take number 5, apatite. Whatever is the hardest is going to be doing the scratching, right? So the harder object will scratch the softer object. So let's say our unknown mineral, you take a 5 and the 5 scratches it, it's going to be a 4, 3, 2, or 1. And if it was a 1 or 2, you'd know because you could scratch it with your fingernail. If the unknown mineral scratches the 5, it's going to be a 6, 7, 8, 9. Does that kind of make sense? And the kids, for the most part, get it, especially the older ones. In the hardness kit, there's also just like a little magnifying glass. There's a little magnet to check if it's magnetite. The other thing we'll look at, so that's kind of hardness. Streak is the other kind of color. So you can scratch the mineral on a streak plate. And we talk about why are there 2 different colors, because if you have a lighter mineral, it's probably going to be better to scratch on the black one. If you've got a darker mineral, better to scratch it on the white one. But this is where they're kind of blown away because that's the true, a little bit more of a true nature of the mineral, because it doesn't always scratch the color that what you see with your eyes. So hematite is mostly kind of black. It's you'll see, I think I have it in there, but it comes in a couple different forms. I have some rainbow hematite that's in there that's kind of looks like a bornite, almost like an oil slick on it, but it's got a reddish brown streak. So it's not always like pyrite, right, which is gold, has kind of like a blackish brownish streak. So that's a little bit more of a true color. Luster, we're good, thank you. Luster is what type of shiny is it? How does it reflect light? Does it have a glassy luster, a soapy, greasy luster, a metallic luster? That's also, another clue. Cleavage and fracture. Cleavage is the way that the atoms all line up. So if it has cleavage, it might be almost like it'll have like flat parallel sides. So it's not that it was cut that way. I say it was born that way, right? And so like if you were to break it, I say all the baby pieces would look like the mommy piece. So that's just how the atoms are lined up. So if it doesn't have cleavage, it just has fracture, and it's just kind of, nondescript, so to speak. Crystal, I bring in lots of different types of crystals. They're all, like the geometric shapes. Is it, almost more like an octagonal? Is it, three-sided, four-sided, six-sided, pyramid, triangular, cube? And we look, they take magnifying glasses because some of the crystals are really small to see, which one it is. Other things, associations like malachite and azurite are often found together. Rubellite and lepidolite are often found together. So I tell the kids that they're mineral friends. And so you find them together. Specific gravity is like how heavy it is, and I'll take two pieces that are like kind of the same size, but like galena and I think I usually use bauxite, and like one's like way heavier than the other. Some minerals react to hydrochloric acid. Magnetite is in there, so that's magnetic. Odor, fluorescence. I did bring my mineral box with my fluorescent minerals for you to see. So that's always, we tease, we call it the whoa box because the kids go in there and they just, whoa. So, yeah.
Sorry for all the questions.
No,
I'm
it's right.
curious in that you mentioned about these mineral friends.
Uh-huh.
So if we're out in the height bringing students on a tour here, are any of those friends usually found along the trails here?
I'm not sure what some of the minerals that are found here, but I would guess no. Like with the malachite and the azurite, it's a very high, I think it's iron content. But some of them you might have to, some of my specimens come from mines. So, but like if you go to buy, you can, I like to have them just on display, so you can see them, but it's probably going to be harder to find them out in nature, I think.
Thank you.
Okay, so atoms, elements, minerals, and now rocks. And so again, solid form, naturally occurring, made from one or more minerals. Now you can't do properties on rocks because if you think of a piece of granite, all of the white that you see are all different minerals. The black you see are all different minerals. The gray is all different minerals. And you can't really do, like a streak test on like a little speck. It's too much going on. The pieces are too small. So we leave that part to the minerals. So the three types of rocks are igneous, sedimentary, and metamorphic. And this is usually covered in 4th grade. So igneous, they're the volcano rocks. And this is really a lot of the Minecraft ones are the igneous rocks. And in this room, so the minerals are in here, the rocks are in there. So I have an igneous poster, a sedimentary poster, and a metamorphic poster. And you're welcome to pick those up. If you want to look more closely at the minerals, I just ask you to keep it in the box because some of the crystals are fragile. But igneous, I tell the kids, think of the word ignite, like when you ignite a fire. And there's two kinds of igneous rocks, intrusive, which are inside the volcano, and extrusive, which are outside the volcano. So when we're dealing with intrusive, you're dealing with magma, and you're going to have the larger crystals because it could take hundreds and hundreds of years for the magma to harden. So you're going to have that opportunity for it to have the crystals form because it's cooling so slowly. Where the extrusive, it might be coming out immediately, right? So that's you're dealing with the lava. So magma intrusive, lava extrusive. And so those, because they cool so quickly, you usually don't have any crystals with that. The granitic and felsic and the basaltic mafic, those are just other ways. I don't do this with the kids. If I, you could probably do it with, maybe 6th grade and up, and that's just kind of talking about like the silicate count, so the granitic felsic are going to be lighter colors, and the basaltic mafic are going to be the darker colors. And then you can also talk about texture. Is it coarse-grained? Is it fine-grained? Is it glassy? Is it vesicular, like pumice that has like little holes? So here's a couple examples. So you've got granite, rhyolite, and pumice. So those are all going to be the lighter colors. But you can see granite, you can see the different minerals in there, right? Because it's intrusive. Where the rhyolite and the pumice cooled very quickly, so you can't really see the different colors. And then gabbro, basalt, and obsidian are going to be the basaltic mafic, and gabbro, again, is intrusive, and the other two are extrusive. Okay, so sedimentary, or sedimentary, however you'd like to say it. First, you're looking at weathering and erosion. There's like a whole kind of sedimentary cycle, if you will. So the little pieces come down. That's where you get the word sediment. And then there's transportation, where they are, they flow down the river, and then they get deposited, and then the little sediment pieces get cemented back together to make your sedimentary rock. So they're mostly found near water and deserts, where water and wind are the main modes of the weathering and erosion, but also the transportation. So they categorize these by the size of the particle, the distance that it's traveled, where it's found. There's different ways that they sort those. Fossils, and this is another one, fossils can only be found in sedimentary rock because fossils have to be buried very quickly so that they're not disrupted. And also they have to be hard parts. So bones and teeth, things like that, are going to survive better than, like skin and stuff like that just kind of disintegrates. So we talk about why, the volcano would destroy it, the heat and pressure of the metamorphism would destroy it. So the main three types of sedimentary rocks are clastic, chemical, and organic, which is the coal family. So these are the clastic. So again, they're sorted like shale, I think, is like 1/248th of a millimeter, right? Which we can't even get our minds around. Many of these you'd have to see the individual size of the sandstone grain of sand, you'd have to look through a microscope. But you can definitely, they can feel the difference in like the graininess as you kind of go up the scale. Breccia and conglomerate, and I have all of these on my sedimentary poster. Breccia and conglomerate I pass them around at the same time, and I say that they're kind of like cousins, because the only difference really is that conglomerate, the little pieces are rounder, where the breccia, they're more jagged, which means the conglomerate pieces traveled down the river farther, so they got more polished as they went along. And then chemical examples: halite, gypsum, travertine, chert. And chert, a lot of the kids haven't heard about chert, but they've heard about flint, because they learned that the pioneers, that's how they would have flint with them to, spark and make a campfire. A lot of them have heard about travertine, because a lot of houses have travertine floors. Halite, because it's rock salt. Gypsum is used a lot in construction. Limestone is used a lot in construction. And then for the coal family, it starts out as peat. And peat is kind of like it's organic material. In Europe, they still have peat farms. And so it's organic material, like, leaves and dirt and bark and grass and everything all kind of compacted together, kind of swampy together. And then it's dehydrated and kind of it's metamorphosed to a certain extent. But they would use that before we had electricity. I would say that, they would use that to heat their homes. But the thing is that it's very smoky, like when you go camping and, you maybe put pine needles or something in your campfire. Well, if it gets even drier, metamorphosed even more, then it becomes coal, which is lignite. So it looks kind of like a raw coal that you might see. It's even often, it's not really shiny. Often it's still kind of brown. So now it's considered a sedimentary rock. And then the next stage is bituminous coal, which is even more black, even more shiny. And then the last stage is anthracite, which now you can see it's like really shiny, really black. And at this stage, it's considered a metamorphic rock. And they do make the connection with like the Titanic. A lot of the kids are really big in Titanic and trains, and how this is how, steam engines and things, this is how the trains and the ships would run back in the day. So many of them connect with it, not just like on the Santa level, I would say, finding coal in your stocking. So, and then the last one, which is kind of, I'd say, like the hardest to really understand. But metamorphic is a really big change. And so I tell them that it used to be an igneous rock, or it used to be a sedimentary rock, or it used to be another type of metamorphic rock, but with extreme heat and extreme pressure over millions of years, deep inside the earth, it's changed into a new type of rock. So I take the former rock, the parent rock, and put it with the new metamorphic version. And I'd say, can you kind of see how this could change into this? If this, and you were kind of pancake it together, granite into gneiss, or sandstone into quartzite, and they kind of get it. They kind of get it. So here are some examples: gneiss, marble, quartzite, slate, phyllite, and schist. And that's when you have to say very slowly and very clearly, so that you don't get yourself in trouble. Or you just avoid it altogether, unless they ask you how to say it. So it does help a little bit, but when you're dealing with millions of years, it is hard, even for me as an adult, to get that into my brain. But we do use a lot of these. We see gneiss around a lot. Marble they see and they've heard of, and slate and all that. So it's not, some of these are common names. And we do talk about the rock cycle just briefly, where if you have magma and then it cools, it becomes an igneous rock. The igneous rock breaks apart into little pieces of sediment. The sediment gets cemented back together to a sedimentary rock. A sedimentary rock, if it's deep within the earth, can change into a metamorphic rock. And because it's deep within the earth, over millions of years and heat and pressure, it can remelt into magma and the whole thing kind of starts again. But again, millions of years. Okay. This I also, fourth grade, we do volcanoes in fourth grade under natural disasters. That's part of natural disasters when we do volcanoes. Also in fourth grade, we've talked about, these are the geology, principles of geology, but they do start to talk about, I don't want to say dating in second grade, but like quick and slow time, and how like a volcano would be an example of slow time, a crystal would be an example of, volcano, quick time, crystal would be slow time. And so how it is kind of hard for our brain because, you know, we only have our bodies and our less than 100 years, you know, to relate to, but just how vast, you know, Earth's time is not our time. Relative dating and numerical dating are different. Numerical dating would be like this rock is 5 million years old. Relative dating would be this rock is older than that rock. So it's more the relation between those. And this also gets into stratigraphy, which if you didn't see Sandra's shirt, it's a beautiful example of stratigraphy, where you are looking and comparing and contrasting the different rock layers. And you really see, I'll show you some of the examples. But so the principles, the main 6 principles are superposition, original horizontality, lateral continuity, cross-cutting relationships, inclusions, and conformities. It sounds very scientific, but it's things that you probably knew but didn't know there was a specific name for them. So superposition is just what position is the rock layer. And the principle of superposition just basically states the older rocks are at the bottom and the younger rocks are at the top. Which when I tell them, I'll have a glass jar and I'll say, okay, if you put in, you know, sand, and then you put in some pebbles, and then you put in some bark, and then you put in some, you know, leaves, and then you put in some moss, what did I put in first, right? You can't put the first things at the very top because of gravity, and they kind of like that, like Miss Brosnan, that doesn't even make sense, of course, you know. So that's the principle. So, but, you know, we don't really think about it that way. But you can see the different rock layers, especially with these, with the Grand Canyon. When they color it different shades, it really, points out how different, you know, how many different layers there are. So, and this is what was on Sandra's shirt, which I just love. And I do this, a simpler version, with the fourth graders, where we talk about the different layers. So like layer E came first, and then G came first, and then L came next, and then C came next, and then M, and then D, and then J, and then A is an intrusion, and you can see it stops because N came after that. And then you have like your tilting and your uplift, and you've got a fault going through it. So it's kind of, I tell them it's kind of like a little puzzle. And the other thing with these, so like every color you can see has like a different design on it. So like F and N, I think, and M, I believe, are sandstone. Maybe N might be shale because the pieces are smaller. J, the brick, is limestone. A is granite, E is granite. So for geologists, like all those different designs actually mean something as well. Okay, original horizontality kind of has a little bit to do with what we see here with that tilting and that uplift. So basically, it just means that the layers had to be flat first before the tilting and the uplifting happened. So where on the second picture, if you're coming across and you have both C and B are both exposed, right, at the Earth's surface, but they're not the same age. Okay, and there's a great place, I love that picture. There's this one I just absolutely love. And if you're driving up the 14, like in Lancaster, there's that outcropping like right alongside of the freeway. I can never quite get a picture because, you know, you're driving 70 miles an hour. But of just some great banding there. Okay, the third one, yeah.
Isn't that the actual fault zone, the last?
I think it's part of it. Lateral continuity, and I love this example because, again, you can see the different layers, right? G is the oldest, A is the youngest. There's no, like, tilting here, but lateral continuity is saying those layers had to be there completely first before the erosion happened. You couldn't do a little sprinkling on this side and a little sprinkling on this side. It doesn't really work that way, right? So it had to be a complete layer and then the erosion happened. So kind of like on this one, you see you've got the erosion at the very top. So that would have had to happen last after all those layers were there. So you can see on the Grand Canyon, and the kids can tell too, like that top layer, even though it's all cut out, you can see it go all the way across. And the next layer, you can see it go all the way across and all the way across. So they're pretty good with these. You know, they can visually, for them, it makes sense to them. Oops. Okay, so just some of the things with geology of Placerita Canyon is that we are primarily a sedimentary rock area with a little bit of igneous and metamorphic. And what is so cool, and I talked to them, and I was like, when we went hiking up into the hills, and we kind of live in sort of a desert area, where did these shells come from? You know, what do you make of this? And some of them know, oh, we used to be underwater. You know, it's like, okay, Mr. Smarty Pants. But but it is really, personally, I think it's really cool. And also, so that's why we have a lot of the shale, a lot of the sandstone, a lot of the conglomerates. We do have some igneous and some metamorphic. The Placerita schist is from the Eocene epoch, which we do talk about in third grade when we talk about fossils. And I do a little bit of that in fourth grade too, where we bring up the geologic time scale. And the kids, they do get a little bit interested in that because then you can bring up the dinosaurs and all that kind of stuff. But that we also are on a fault zone. And we also talk about, well, you know, coal and oil, those are fossil fuels. You know, you can bring in that whole thing. And have you seen, you know, some of the oil pumps, you know, all around? We talk about that. Faults, synclines are when, like, you have them all over. Syncline is when the hill goes down. Anticline is when it goes up. And stuff that, you know, you guys have all been learning about, I'm sure, with the gold. This is a Dibley map. And if you've never seen a California geologic map, this is just Placerita Canyon. And so every color you see is a different type of rock. And if I remember, like all of the yellow ones are all sedimentary and these down here are metamorphic. So you can only imagine, it's like if you come from a, maybe a Midwestern state where there's not a lot, maybe going on geologically, a California geologic map is crazy. There's like a million different colors, like all swirled together. And this, like the little T's, that shows like the slope. Those are called strikes and dips. And they'll be like, you can find these for any area. And also like the little waves, that shows the elevation. So the closer the lines are together, the steeper it is. There would be like a key to show you what type of rock QT stands for, that type of thing. But these are all, you can kind of get into the woods with this, but they're still kind of fascinating.
Have they showed where the fault line is? Do they color it?
I think it is on here. I thought it was on here. It's right, right here. I guess I could use, there we go. Isn't that nice? Got a little laser on here.
What were the origins of this? Where are the sources of it?
I got this from one of my professors at COC. But Dibley is, I think it's Dibbley, I think, and you can find them for anywhere. And I think that's it. So.